What generates electricity in a battery? This is the Lemon Battery Lab. Take a look at what we have on the table. Everybody here recognizes our samples up here as being batteries. Some of them probably power your favorite toy or your flashlight, even your watch. But as you look at this, let me show you something else that might become a battery. It's a lemon. I know you're wondering, that is a battery? Well, it's not quite a battery, but we're going to make it into one. Let me tell you how we're going to do that. If you think of a structure of a battery has nothing more than two electrodes. One of them happens to like electrons more, so it will draw electrons towards it. And somewhere in between these two electrodes is something called an electrolyte, usually an acid. It's basically something that will act as a conduit to bring the electrons from one electrode to another. That's how those electrons flow. In today's lab, we are going to take this simple lemon and we're going to turn it into a battery. Are you ready? Let's get started. Now let's go over the materials for this lab. We are going to start with our lemon, which I will show you that I will roll around because I need to get the juices running in there. This helps break up some of those cells. In addition to that, we have a wireless voltage sensor, a knife, because we need to make little cuts on the lemon in order to put our electrodes in. Let's look at our metal electrodes. Today, we are working with a strip of copper, a strip of zinc, a strip of lead, a little piece of magnesium. Now, if you were running this experiment at home, don't hesitate to look at the different kinds of metal objects in your home that you could use for the same experiment. For example, copper pennies work just fine. This is a galvanized nail and a galvanized screw. Both of these will work very well as well. We always have a piece of steel wool nearby because just in case there is some kind of metal or compound buildup on your metal strips, it's always good to actually shine them up a little. And as an optional part of this laboratory, we have an LED lamp that's connected to alligator jumper cables. We're going to see, or you're going to be seeing, whether or not the battery that you create today is able to light up that LED lamp. Are you ready? Let's get going with the rest of this lab. The SparkView file for this lab can be found under Essential Chemistry. This is Lab 18C. And I've actually already prepped a little bit for you by writing down the combinations of metals that I'm going to be using today. So let's get started by preparing our lemon. Remember that we already rolled it a little bit to get those juices running inside. I'm simply going to take a plastic knife and very carefully cut two little slits on the lemon to help me insert those electrodes in there. I'm going to start with my copper and my zinc. So here's my copper, here's my zinc, and I'm going to put them right into the lemon. I'm going to use the little alligator clips to connect them. And I will see what kind of voltage I am getting. Oh dear, we have a negative voltage. That is not good. That means that these electrodes are not oriented correctly. So what I'm going to do is I'm simply going to take one and the other and I'm going to switch them. Oh, that looks better. So far, we have a reading with copper and zinc. We have a reading of 0.979. I'm going to press the little check button here. Excellent. Now we're going to switch one of those electrodes. We're going to take the copper and we're going to switch it out with the lead. So for this, we are reading 0.586 volts. Not quite as high, but not too bad. So we're going to put a little check mark on that. Now we're going to take the zinc out and we're going to put in the copper. Oh, we're back to that negative thing again. So it looks like we're going to have to do a little switcheroo once again. There we go. So for copper and lead, we are reading 0.415. Put a little check mark on that. And finally, we're going to switch out the lead. And we're going to put in a little bit of magnesium. Holy cow, we have 1.887. Excellent. We're going to stop that right here. So now we have the data for the 4 different metal combinations that we did today. If you are doing this at home and you have access to other kinds of metals, this is a good time for you to actually try those different combinations of metals. Now we are ready to analyze this data. Now that you have the data for this lab, I would like for you to rank which combinations of metals gave you the largest voltages. And that is important because of what's happening in the next part of this lab. If you happen to use other metals as well, make sure that you record in your worksheet exactly what those combinations are, who was the negative charge, who was sitting at the negative side of your battery and who was sitting on the positive side of your battery. Because as you can tell, when you get those negative readings, the polarity matters. So as an extension to this lab, all you really need to think about is what would it take to light this little LED? Now, I know it looks tiny, but it takes quite a bit of energy to light up that little light bulb. And so you want to look at your data and maybe make a great guess as to what combination you're going to need. Let's say you had only, let's look at one of our poorer combinations. Let's look at lead and zinc. Let's say you had lead and zinc. You know that that voltage isn't the best, but what if that's all you had? And you somehow had to make a lemon be a functional battery for this LED. The obvious answer is maybe you just string together a bunch of different lemons. That's one thing you can do and make a huge two lemon battery. What if you only had one lemon? That is my challenge to you. If you only had one lemon and you somehow had to make that metal combination work for you, how would you do it? And that's the lemon battery lab.